students. I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today I'll discuss about the some problem statement on Tanner's diagram. As in the previous lecture, I have discussed about the Tanner's diagram, like why this Tanner's diagram has been useful, and this Tanner's diagram with respect to the composition of waste means total moisture, ash content, carbon content, and total moisture content of the waste. So this is the whole picture that is related with the municipal solid waste management. Municipal solid waste management. So we are at that point of studying this at this point, like transformation of waste. Now we are discussing about the transformation of waste. Transformation of waste. So for this transformation of waste, waste as a fuel, we are going to study waste as a fuel. Waste as a fuel in incineration. So, municipal solid waste as a fuel can be used in the incinerator plants, because this incinerator plants will be run with a by burning this MSW waste, and very high heating value will be produces. That's why this Tanner's diagram will be there, because this Tanner's diagram will give you idea about the composition of the total waste. And today we'll discuss some problem statement on this Tanner's diagram. So let's first of all let's discuss about the why this waste as a fuel. What is the background of this study? So waste to energy plant is a plant. Waste to energy is a plant that is going to burn out the either MSW, or some people will call it as a trash or garbage, to produce a steam in a boiler that is used to generate electricity. So this is the actual meaning of this waste to energy plant. What this plant is doing, this plant is burning the MSW or garbage at a very high temperature to produce steam, in a boiler, and that is used to generate some of the electricity. MSW is a mixture of energy rich materials like paper, plastic, yard waste, and product from wood. So this MSW is having a composition of lots of things. So what it is, first of all, it is a mixture of paper, some plastic, some yard waste, and some wood products. That's why it has a very high heating capacity. High heating capacity. High heating capacity of this MSW. That's why if we will use this because of this reason only we are using MSW in a boiler, so that it will produce a very high heating temperature. With this very high heat, we can use it to generate electricity. And next point is that waste to energy plants reduce it 2000 pounds of garbage, means it is going to reduce up to 2000 pounds of garbage to ash that will be mostly weight around 300 pounds and to 600 pounds, and they reduces the volume of waste by about 87%. So one of the very important thing that is related with the waste as a fuel is volume reduction. Volume reduction of waste. Volume of the waste is reduced up to 87%. Up to 87% of the total volume of the waste is reduced by this method. So waste to energy is a plant that is reducing like 2000 pounds of garbage to ash weighing about 300 pounds to 600 pounds, and they reduces the volume of waste by about 87%. And it is a mixture of like why this MSW is using, because MSW is a mixture of waste. So in this mixture of waste, it is having a very high heating value. Things like some paper is there, either some plastics, some wood products are there. So if we will burn all those things together, they will produce more and more heat. So and we can utilize this heat to produce steam in a boiler that is used to generate electricity. That is the main benefit of using waste as a fuel, because to burning a waste is a very good and viable option for this utilization of waste. So because of that only, now we'll discuss about the different parameters, which is the important parameter that is associated with this point, that is waste as fuel. So first of all, as we have studied in the last class, like the moisture content, carbon content, ash content, all are the key parameters that has to be studied before knowing its the heating capacity, or if we will give every parameters on an ideal condition, then though no auxiliary fuel will be required. If something will be missing, then auxiliary fuel will be required. When then the heat, then the waste will not burn by itself only. We need some auxiliary fuels. So first of all, the problem statement is this is the study from China and Philippines. So which country will require auxiliary fuel for combusting their waste? So for the combustion of their waste, which of these two country required auxiliary fuel? Because whatever is the parameters, as per the parameters has been given: combustible percentage, ash percentage, moisture content, total calorific value. So these are the important parameter. On these each parameter some values are there. So it is from Manila and Ganjur, China, Philippines and China. So first of all, China value is 22.3, 28.8, and moisture is 48.9. When we see that the values of Philippines solid waste, we will see that combustible percentage is 37%, ash is 15%, but moisture is 46%, and lower calorific value will be 6800 kilojoule per kg. So this is the characteristics of the municipal waste. So we have to find out for the burning of which country waste no auxiliary fuel will be required. Means which either it is in a these parameters is in a ideal condition, or some they are lacking in the ideal condition. So first of all, we'll calculate like this. This is the given moisture as content and combustible matter for the China. Okay, so in China, moisture content is less than 50%, ash content is less than 60%, and combustible matter is not less than 25%. And on the other side, this will be given from the Philippines, where W is less than 50%, ash content is less than 60%, and combustible matter is more than 25%. So first of all, we'll calculate it's in a ternary diagram. So for Manila waste, for Philippines waste, this will be the ternary point of view, and for China, this is the point of view. See, because how Manila, for Manila waste, we can say that W is for 50%. So this is the 50%. See, this is the, so see, this is the 50% of it. Then ash content is less than 60%. That's why the point is here only. And then again, the carbon content is more than 25%. So this will be point. This will be the main point for this Manila and Philippines waste. And for China, what it is given, it is less than 50%. Okay, but the ash content is 28.8%. That's why the point is located here only. So this is the point for China, and this is the point for Manila waste. So in this, we can say that the waste from Manila would not require, because it not required any auxiliary fuel, while the waste from China would require. Means Manila waste would not require auxiliary waste. On the other hand, China will require, because it is coming outside this shaded area. That's why the this is the Taylor diagram. In this, for this diagram, with all the different combustible matter and ash percentage and moisture percentage, we can calculate that the auxiliary fuel will be required or not, or the waste will have it is they are the key parameter. So they are sufficient, they are capable of burn by itself only. So if we did a comparative study of two cases, that is from China and Manila. So Manila Philippines waste is like they are having a standard category. That's why this Manila Philippines does not require any kind of auxiliary fuel for the burning of their own waste. So what is this? First of all, we'll discuss about the heating value. Heating value is a very important thing regarding this waste as a fuel. Some variables are used to determine whether a waste can sustain the combustion process without supplementary fuel. So without any supplementary fuel, without any extra fuel, these are the some of the parameters which we should know. First is the lower heating value, that is H low, and high heating value H high. So this it is a variable. It can use to determine whether a waste can sustain the combustion process without supplementary fuel. So first is lower heating value. Energy released upon complete combustion of a fuel, carbon to CO2, hydrogen to H2O, sulfur to SO2, and water is evaporated, leaving the process in its evaporated state. So this is called as lower heating value. Means energy released upon complete combustion, means complete combustion is there, either from the complete combustion is there from it is from the carbon to CO2, hydrogen to H2O, and sulfur to SO2. If three steps is there, carbon to CO2, then hydrogen to H2O, sulfur to SO2, and water is evaporated, leaving the process in its evaporated state. So it is called as lower heating value. And higher heating value is energy released at complete oxidation and water leaves the combustion process in its liquid state. It expresses the theoretical maximum energy released from the fuel. Higher energy heating value means energy released at complete oxidation and water leaves the combustion process, means energy released during the complete oxidation and the water will leave the combustion process in its liquid state. It expresses the theoretical maximum energy release from the fuel. It expresses means theoretical total energy released from the fuel is called as higher heating value. Lower heating value means a little amount of energy is required, energy released when complete combustion of fuel is there. It is like from carbon to CO2, hydrogen to H2O, sulfur to SO2, and water is evaporated, leaving the process in its evaporated state. This is called as lower heating value. Higher heating value is called as energy release at complete oxidation and water leaves the combustion process in its liquid state. It expresses the theoretical maximum energy release from the fuel. So this lower heating value and higher heating value is a very important factor while determining the heating capacity of any fuel. So the difference between heating value lower and higher is a heat of condensation of water vapor content in the flue gas. That difference is called as heat of condensation of the water vapor content in the flue gas originating from moisture in the waste and moisture generated by oxidation of hydrogen bond within the chemical structure of the waste. So it is called as moisture in the waste and the moisture generated by the oxidation of hydrogen bonded within the chemical structure of the waste. So H high is equal to H low plus W plus H into 8.937 into 24.45 kilojoule per kg. So where W, as we know, is a moisture content, height is H is equal to weight, that is percentage of the hydrogen. So the difference between heating value at low and heating value at high is the heat of condensation in the water vapor content in the flue gas originating from moisture in the waste and moisture generated by the oxidation of hydrogen bond within the chemical structure of the waste. That's why H heating value is high is equal to heating value of low plus W plus H into 8.937 into 24.45 kilojoule per kg. W represents the total moisture content, H represents the weight percentage of the hydrogen. Now, how to calculate H low, heating value at low can be calculated from the elemental composition. As we know that the elemental composition is CHNO, and chlorine, and it is expressed using an empirical formula suggested by the Scanpay 1976 as like H low is equal to kilojoule per kg is equal to 348 carbon percentage plus 939 hydrogen percentage plus 105 sulfur percentage plus 63 nitrogen percentage minus 108 oxygen percentage minus 24.5 H2O percentage. So CHSNO and H2O is equal to percentage weight of carbon, hydrogen, sulfur, nitrogen, oxygen and water in a waste. So it will represent like the CHNSO is the NH2O is equal to weight of carbon, hydrogen, sulfur, nitrogen, oxygen and water in the total waste. So on this basis, we will define the two terms. The first term is the calorific value, which is often used instead of heating value. So that we are going to use the value called as calorific value. Calorific value is of again two types. First is a net calorific value and gross. Sometimes net or inferior may be used for lower heating value. And for total heating value like high heating value, gross, superior and upper words is used for the higher heating value. Mainly in our India, gross calorific value GVC represents higher heating value and net calorific value NCV represents lower heating value. GCV, gross calorific value, gross calorific value, big value. NCV, net peak value. So NCV will represent lower heating value. GCV, gross calorific value, represent higher heating value. And then this calorific value is now used in terms of this heating value. So calorific value is either net you can say, or inferior calorific value for the lower heating values, or gross, superior or upper. Some words are there that is maybe used for higher heating value. In India, GCV is gross calorific value and NCV is net calorific value. It is represents lower heating values. So we are going to calculate one problem statement that is based on the this chemical composition. So consider 1 kg of waste with the following chemical composition. 1 kg of waste is there. 1 kg of waste is there. With this 1 kg of waste will have this composition. C is equal to 30%, H is equal to 4.3%, S is equal to 0.1, nitrogen is 1%, oxygen 24%, chlorine 0.5%, H2O 20%, and ash is 20%. Estimate its lower and higher heating value. Means we have to estimate lower and higher heating values. Everything is given like CHSNO, chlorine, H2O and ash. For this for a 1 kg of waste, means total amount is the 1 kg of waste and their chemical composition is like that. So we have to calculate its lower and higher heating values. So lower heating value can be calculated like this. H lower is equal to kilojoule per kg. H lower is as it is energy, so it can be calculated in the kilojoule per kg. So is equal to 348 C percentage plus 939 H percentage plus 105 S percentage. These are the total elemental composition minus percentage minus 108 oxygen percentage minus 24.5 H2O plus percentage. So higher heating value at low temperature kilojoule per kg is equal to 348 into 30, 348 into 30, 348 into 30 plus 939 into 4.3 plus 105 into 0.2 plus 63 into 1 minus 108 into 24 minus 24.5 into 20. So is equal to 11480 kilojoule per kg and 11.48 megajoule per kg. This will be a lower heating value. Lower heating value. And for higher heating value, what is the formula? it is like for higher heating value, H low plus W into H into 8.937 and 24.45 kilojoule per kg. So H low is already, we have calculated 11,480. 20 is given as the percentage of the moisture, and the weight is 4.3, and this is already given, so 24.45. So 1440 and 12.9 megajoule per kg. So for higher heating value, its value is 12.9 mj per kg, and for lower heating value, it is like 11.48 megajoule per kg. In this way, we have calculated the lower heating value for a 1 kg of garbage, 1 kg of MSW, and higher heating value for a 1 kg of garbage. So for higher heating values, 12.9 megajoule per kg is there, and for lower, it is 11.58 megajoule per kg is there. Now we'll discuss about the RDF. RDF is the refuse drive fuel. So another waste is from that, waste from fuel from waste is like RDF. RDF is a refuse derived fuel. It is defined as a fuel derived from combustible waste, fraction of solid waste like some plastic, wood, pulp, or any organic waste other than chlorinated material in the form of pellet or fluff produced by drying, shredding, dehydrating, and compacting of solid waste. As per the Solid Waste Management Rule 2016, RDF can be defined as a fuel derived from the combustible materials, combustible waste fraction of solid waste like some plastic, some wood, pulp, or organic waste other than the chlorinated material in the form of pellets or puff, and it is produced by either by drying, shredding, dehydrating, and compacting of solid waste. Composition of RDF has higher concentration of combustible matter than those in the parent mixed MSW. So how this RDF can be made? So it is an integrated solid waste management hierarchy. So you can see that all sources reduction and reuse is there, then recycling and composting. Next point come is the waste to energy. And all source reduction is the reuse is the most preferred, and this will be the least preferred. So RDF can be made, it can be derived from a combustible waste fraction, means from a waste fraction that will be combustible. So combustible waste fraction RDF can be derived, and it is either a combustible waste material or those material like that can be combustible. So plastic, wood, pulp, or organic mass waste is there other than chlorinated material in the form of pellet or fluff produced by drying, shredding, dehydrating, and compacting of the solid waste. So this is there, and this is called as RDF, refuse derived fuel. The fuel which is derived from the refused, like from waste, fuels derived from the waste, and it is a combustible material. That fraction of MSW that can be a combustible. So this will be like a very important, and the composition of RDF has higher concentration of combustible matter than the parent mixed MSW. Composition of RDF has more concentration of combustible material, more concentration of combustible material like combustible material than those in the parent mixed MSW. It is like a RDF is there, refuse derived fuel, and it is mostly used nowadays because it will be plugged. It will be like that fraction of waste that can be combustible, and it will be stored in the form of a pellet. It can be stored in the form of a pellet, or it will be produced by drying of waste and then shredding, dehydrating, and compacting of solid waste. Now comes to the next point. The quantity of RDF produced per ton of MSW varies depending upon the type of collection, pre-processing, and composition of waste sources. So now the quantity of RDF that is produced per ton of MSW will varies depending upon the type of collection. Obviously, it will be vary because of the collection system, pre-processing, and composition of the waste also. Because of collection system, collection system, pre-processing, and composition of waste. And the quality of RDF depends on the characteristics of incoming waste feed. Segregation into combustible and non-combustible is a prerequisite. Means first point for this RDF obtained fuel is like segregation. It will start from the segregation point. Segregation is the prerequisite to obtain this RDF. Segregation, because segregation to segregate the combustible and non-combustible material, because after segregation then only you can obtain this RDF, because RDF is a quantity of RDF produced per ton of MSW. It will varies depending on the types of collection, like pre-processing and composition of waste source also. And it is a characteristics of incoming waste feed. It is a characteristics of incoming waste feed, and segregation into combustible and non-combustible part is the prerequisite. It is a very important before obtaining this refuse derived fuel, because when we will do segregation then only this can be possible. Combustible and non-combustible materials should not be with this waste, because non-combustible cannot, like some construction and demolition waste, some street waste, some inert material is there. So if some time of non-combustible materials would be there, then this RDF cannot be achieved. And RDF can be formed because of the is basically the combustible fraction of a waste is, we can say that RDF is nothing but a combustible fraction of a waste is called as RDF, refuse derived fuel. Now this is like a net calorific value of refuse derived fuel versus coal. Means this is a comparative study of this RDF with the coal. So net calorific value of refuse derived fuel versus coal, it is given like that. Indian coal will have 2500 to 5000 of net calorific value. Mixed plastic 6000. Segregation of municipal waste like plastic, cloth, jute, paper, multi-layered polythene, multi-layered packaging, thermocol, means segregated waste. Segregated MSW will have 2000 to 2500 value, net calorific value. So some of the industries is there that are requiring high calorific fuels like iron and steel, like 9000 kilocalorie. Using waste as a fuel became now impractical. And for few industries like cement, it will require low calorific value like 300 kilocalorie. So this will be the comparative data for this refuse derived fuel versus the coal. So if we can say that Indian coal will have 2500 to 5000 of calorific value, but this mixed plastic will have more. They have 6000 of kilocalorie net calorific value. And just like that, some segregated MSW is there. In a segregated MSW also, we can say that its calorific value is around 2000 to 2500 kilocalorie. So for some industries like cement, it will require low calorific value, or some industries will require high calorific value. So like the iron industry, steel industry, they will require high calorific value like 9000 kilocalorie. Waste as fuel become impractical. And for industries like cement, they require low calorific value fuel like 3000 kilocalorie. So this is the utilization of refuse derived fuel. And it is a data for the comparison between the refuse derived fuel and the coal. Now these are the references for some of the textbook which you can follow to get in-depth knowledge of all these things. Because now you have to study if you want to study in depth of this low calorific value and that waste characteristics and the composition of waste, you can use this textbook also. So now I'm concluding my lecture. And today I have discussed about the problem statement that will be regarded with the Taylor diagram. And some problem statement will be like we have to calculate, we have given the waste composition of two countries, Manila and China. And with this much of parameter, how can we calculate that they will require some extra fuel, supplementary fuel, or it will all their solid waste will burn by them only. On this basis, we have calculated some of the numerical, some of the problem statement, and some of the problem statement regarding with the low calorific value and high calorific value. And we have also discussed about the refuse derived fuel. So at this point, I am concluding my lecture. If you have any queries, if you have any question, you can write in the comment box, or you can directly mail me to the my given mail id, that is shikha.panday@the rate gmail.com. You can directly mail me on my mail ID. Okay, thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.